The space endeavors of India have a historical timeline tracing back to the 1970s, which is a remarkable feat considering they are among the rare independent nations that have successfully developed and executed a sequence of orbital rockets. During the late 1990s and early 2000s, India gained prominence as a reliable source for affordable satellite launches. Moreover, India has even accomplished missions to the Moon and Mars with their spacecraft. Nonetheless, India's journey into outer space has not been without its challenges. The recent setback in their SLV rocket test serves as the latest in a series of hiccups. However, when we analyze the overall picture, India has made noteworthy contributions to human spaceflight, although many people remain unaware, either partially or completely. This calls for rectification. The genesis of the Indian Space Research Organization dates back to 1969, just a month after Neil Armstrong's historic moonwalk. The Indian populace was both inspired by the grandeur of this achievement and pragmatic in their approach. Their intention wasn't to dominate the space race, but rather to recognize the significance of maintaining a space presence alongside established global powers such as the United States, Russia, and China. The Indian philosophy centered on efficiency and cost-effectiveness while securing their position in the realm of space exploration, avoiding lagging or being left in obscurity. Contrasting this approach with NASA's funding over the years, where the agency's share of the U.S. federal budget peaked in the 1960s, consuming over 5% of the nation's resources, the U.S. space program experienced a rapid burnout and collapse. Even with a slow and steady philosophy embedded in their strategy, India managed to place their maiden satellite into orbit as early as 1975. This was the Aryabhata, named after a 5th-century Indian mathematician and astronomer. Due to the absence of a homegrown rocket, the satellite hitched a ride on a Soviet launch vehicle. Despite its short-lived success, losing communication after 5 days, the Aryabhata's distinctive 26-sided polyhedron shape left an indelible mark in the early space exploration era. An illustration of the satellite even adorned India's 2-rupee bill for decades, and it found a place on a Soviet postage stamp in 1984. Substantial progress ensued in 1979 when India engineered their first rocket, embarking on attempts to launch indigenous satellites using the Satellite Launch Vehicle, SLV. This modest rocket, standing at 1 meter in diameter and 22 meters tall, had 4 stages powered by solid propellant engines, capable of delivering payloads of up to 40 kilograms to low Earth orbit. Although the initial launch effort faltered in 1979, a subsequent endeavor in the following year proved successful, placing the Rohini 1 satellite into orbit. This accomplishment marked India as the 6th nation to achieve orbital spaceflight. Further advancements emerged with the Augmented Satellite Launch Vehicle, ASLV, an enhancement of the initial design by incorporating 2 side-mounted boosters. By 1992, this innovation enabled India to elevate payload capacity, culminating in the deployment of a 106-kilogram satellite by 1993. After 2 decades of research and development, India unveiled the Polar Satellite Launch Vehicle, PSLV, a substantial upgrade that bolstered the country's space program. Comprising 4 stages, the PSLV featured a solid fuel core booster and up to 6 strap-on side boosters in its XL configuration. The second stage featured India's first liquid-fueled engine, the VCS, a counterpart to Europe's Viking engine. The third stage reverted to solid rocket technology, while the fourth stage utilized liquid fuel. These innovations enabled the PSLV to transport nearly 4 metric tons to low Earth orbit and almost 2 metric tons to polar orbit. This rocket emerged as a global mainstay, providing the most economical access to outer space. Throughout the late 1990s and early 2000s, the PSLV completed 53 launches. India adhered steadfastly to their frugal and efficient approach to spaceflight. Astoundingly, they managed to design and construct a functional orbital rocket with a fraction of the funding invested by other nations. In comparison, India's annual expenditure was merely a fraction of NASA's monthly budget. This cost-conscious approach allowed India to offer PSLV flights at a significantly reduced rate. Launching a kilogram of weight into space using the PSLV cost around $8,500. India continued to advance its rocket program, upgrading its launch vehicle to the GSLV, which now had geostationary orbit capability. This upgrade swapped out solid rocket boosters for liquid-fueled hypergolic ones and featured the GSLV's first hydrogen-powered rocket engine. Another advancement came in the form of GSLV Mark Eli, reverting to solid-fueled side boosters with gigantic S-200 strap-ons, boosting payload capacity to 10 tons to low Earth orbit within a broader 4-meter ferry. However, the journey has also seen a few setbacks. The Chandrayaan-2 mission, anticipated as another triumph, aimed for a controlled lunar landing with the Vikram lander. Intended to study and map the lunar surface, things went south. Launched in July 2019, the mission successfully reached lunar orbit, deploying the Vikram lander as planned. Yet halfway to the surface, disaster struck. The vehicle encountered a glitch, causing it to veer off course, leading to a collision with the moon's surface at around 100 meters per second, scattering debris across kilometers. Despite these hiccups, India continues to look ahead with an ambitious spaceflight agenda. Their latest rocket development is the SLV, Small Satellite Launch Vehicle, a contemporary take on the PSLV, catering to the trend of smaller satellites. Unfortunately, the initial launch of the SLV did not go as intended. A software glitch hindered the final stage from firing properly, though it wasn't a complete failure. India's future space plans are grand. They're eyeing another lunar shot, gearing up for human spaceflight, and even planning an interplanetary venture to Venus. The Chandrayaan-3 mission is set for 2023, a follow-up to the Chandrayaan-2, aiming for a lunar lander and rover. In 2024, India plans to send its first human spaceflight mission, named Gaganyaan. Originally targeted for 2020, safety concerns led to delays. The GSLV Mark Eli rocket will carry the Gaganyaan crew capsule designed for 3 people, intending for a 7-day orbital test. If successful, these astronauts would become India's first in space, joining the ranks of the US, Russia, and China. Looking forward, India has its sights on Venus, with the Shukrayaan mission aiming to orbit the planet and study its surface and atmosphere. Aspire to launch in December 2024, India's space pursuits, while not mind-blowing, showcase a steady performance in a space race alongside countries with significantly larger budgets and resources. Just imagine the possibilities if their successes continue and their budget grows.